Hello, scholars, and welcome to our lesson on properties of parallel lines cut by a transversal. This is in angles and triangle theorems, and the goal is that you will be able to identify different types of angle pairs made when a line crosses two parallel lines. The reason we're doing all of this is because angles and later on triangles are a big part of our daily world, both in a physical and in a more digital sense. Angles and triangles alone are used for a lot of our design processes, from architecture, construction, to digital 3D models. You need to have a grasp of angles and triangles to successfully work in those areas. Let's begin. First, with a warm-up pop-up. So, we have a few different steps here. One, what is the value of our mystery angle? We have 72 and mystery angle. So first, what is the value of that angle? Now that you have the value of that angle, when we extend the line, what are the values of our other mystery angles? Oops. Sorry, I didn't mean to go back there. Doing a check-in. So, first and foremost, you hopefully noticed you're going to be using a lot of different angle knowledge today. You hopefully first noticed that you have a straight line with your beginning angle, right? Meaning this whole thing should be 180 together. If you remember that, good job. From there, if you took 180 and cut out 72, you should have been left with 108. So if you thought our first mystery angle was 108, you are totally right. From here, there's actually a lot of different angle rules you could use to find these other two angles. For me, I would want to use the vertical angle rule. Remember, these are two lines crossing each other, meaning these opposite angles are the same exact measurement. So if this is 72, then down here, we should also have 72. And if this is 108, then over here should also be 108. Now, no matter what angle rules you used, if you got that in the end our angles are 72, 108, 72, and 108, then you found your angles successfully. I'm going to clear this up. And let's see what we're actually dealing with today, which really has to do with kind of what you're doing in that warm-up. When two parallel lines are crossed by a transversal line, we can use what we know about supplementary and vertical angles to prove some helpful angle rules. So, keep in mind, all of these angle pairs are congruent. Remember, congruent means equal, the same. So, alternate exterior angles are congruent. Alternate interior angles are also congruent. And corresponding angles are congruent. Next thing to discuss. How do you find all the angles of parallel lines cut by a transversal? Using all of these angle rules, we can determine that when two parallel lines are cut by a transversal, all 8 angles only share 2 angle measures. 4 share the first angle, and the other 4 share the other angle. So even though it can look really complicated to see 8 different angles, in the end, there's actually only going to be 2 different angles you're going to be sharing between these 8 angles. The first rule we use is our supplementary rule. This is just like in the warm-up, which is this is a straight line here, meaning if we know what one angle is, we can find the other angle by taking it away from 180. Now that we know what that is, we can then use our vertical angle rule, again, just like the warm-up, where if I know what this angle is, I know the opposite one over here should be the same. Same thing with the red one. If I know what this is, I know what the opposite one should be. And just like that, we filled in a whole section. Now that one whole section is done, we can use the rules of corresponding angles, which, as we just said, corresponding angles are the same. So if we know that what the top left angle is, the other top left angle should match. Same thing with top right to top right, bottom right to bottom right, top left to top left. It should give us all those same matching angles. And this is always true for any two parallel lines cut by a transversal line. In the end, there's actually only two angles that get used. The original one you start with, and the one you get after you take it away from 180 to get the other one. Then all the rest of the angles, just in some way using vertical angles and corresponding angles, share those two. Let's actually use that as an example. They're telling us here, the measurement of angle 3 is 55. Come back here, mouse. Oh, you're good there. What are the angle measures of all of the other angles? So first things first, let me get my pen tool out. And they said angle 3 is 55. So I do want to write that here. Oh my gosh. I just did a lot right there. 55. So like I was saying before, if we know what 1 is, I can either find out what angle 2 is or angle 4 is. Because I'll do some color coding, these make a perfectly straight line together. Which means that I can find out what the missing piece is, which is step 1. Use our supplementary angle rule to find the adjacent. Adjacent just means the angle next to it. So I'll do that down here. Let's see. Ooh. If I take 180 and I subtract the 55 I was given, let's see, 180 minus 55, I get 125. So that is the angle measurement for 4. So I have two angles now, the one I was given and the one I got by subtracting it from 180. Step 2 is use our vertical and corresponding rules to find the other angles. So again, if I use my vertical angle rule, this angle 3 and angle 1 are opposites of each other on the angle line, meaning they have the exact same angle measurement. So they're both 55. I use the same rule with my 125 that angle 4 and angle 2 are on opposite sides of these vertical cross lines, meaning they should match. Lastly, using corresponding, this whole thing should just be copied over to the other side. So angle 6 should be 125, so should angle 8. And angle 7 and 5 should be 55. And just like that, I went from having one angle to all 8 angles solved. So it's very satisfying to use all of our angle pairs all together to get all of our missing angles. And that's all you do. Once again, take the angle you've been given, subtract it from 180 to find the angle next to it. From there, use your vertical angles to match things across, then use corresponding to take that whole set and just copy it over, same positions on the other cross section. And that's it. So with that, pause if you need to get your notes in, but I'm going to clear up and let you work on a U-try, meaning it's time to see what you know so far about parallel lines cut by a transversal. I'll read it and you can pause and work on it on your own. The measure of angle 1 is 30. So before we do anything, I will want to note that in as you would want to note that in. That was angle 1. So angle 1 is 30 degrees. What are the angle measures of all the other angles? All right, doing a check-in. Pause if you weren't yet ready. The first thing you hopefully did was find out what our adjacent angle, the one touching, is, which you could have done 1 and 2, or you could have done 1 and 3. Tomato, tomato. If you ended up doing 180 minus 30, and you got our missing angle, and you got 150, ooh, my lines are a bit messy today, then you would have been absolutely right. So if you said angle 2 was 150, you're right. From here, you should have used your vertical angle rules, meaning that angle 2 and angle 3 are on opposite sides of the crossing line. So if you said angle 3 and 2 are both 150, you were right. If you did the same thing with angle 1 and 4 and said, well, they should both be 30, you are right. If you then take this whole thing and just copy it over to the other side, meaning we should have 30, 30, 150, and 150, then you successfully found all of your angle pairs. If this looks messy, you could list it off here as well. So you could say, well, angle, and you can always do it this way too. I could say that what is 30 degrees? I can make a list and say, well, angle 1 is, angle 4 is, angle 5 is, and angle 8 is. Same thing with 150. If you like keeping things a bit more organized, because it can look messy inside of it, 150 shares angle 2, angle 3, angle 6, and angle 7. But in the end, look at it. All 8 angles just get split in half. Half have 1 degree, half have the other. With that, pause if you need to make any corrections, but I'm going to clear up and go to the closing, which is that we can use what we now know about supplementary, vertical, and corresponding angles to quickly find all 8 angles when only given 1. Almost like a magic trick on how quickly you can find all the other angles when you just have 1. With that, I will see you in future lesson videos, but goodbye for now.